Welcome to our mathematics lesson. I am Euclidean, and this lesson is proudly brought to you by the Gauteng Department of Education. Grade 10, we're continuing with our lessons. We're doing the midpoint theorem. It's very, very important. Please pay attention during this lesson. It is very, very important for you to understand the midpoint theorem. Let's be ready for our lesson. Please make sure you have your book with you, your pencil. We're going to be drawing. We're going to draw a triangle. Make sure you have a pencil and a ruler. Even if you don't have those, it's fine. We're going to even draw rough sketches. It's okay. Let's be ready for our lesson. Right, let's start. Midpoint theorem. Do you remember midpoint theorem? What is it about? At the end of the lesson, you should be able to investigate line segments joining midpoints of two sides of a triangle. We want to see this line segment which is joining the midpoints of two sides of a triangle. What does it do? What does it do? We join midpoints of the two sides of a triangle. What does that line segment do? Or what are the properties of that line segment? That's what we want to find out in this lesson mainly. Okay, remember our WhatsApp line 063-508-1301. Please let's engage each other during the lesson. Okay, right. Now we are going to prove the midpoint theorem. We're going to do it at the last part, the proof. If the time allows, we're going to do the proof. Okay, and then what have we done in grade 8 and grade 9 that is going to be used in this lesson? Remember, we have done parallel lines cut by the transversal, geometry of parallel lines. You have to remember that. Do you remember corresponding angles, alternate angles, co-interior angles? Still under geometry of straight lines there. Adjusting angles on a straight line. We have done that in grade 8, even from grade 7, I think. 7, 8, 9, we have done that. Complementary angles, I've done those. Supplementary angles, complementary angles, remember, add up to 90 degrees. Supplementary angles add up to 180 degrees. Angles around a point, vertically opposite angles. Basically, we've done geometry of what? Of straight lines, the intersecting lines and parallel lines. Right, usually we start with our baseline activity. I want us to do this activity in 5 minutes. A, just easy. According to the diagram there, AD is equal to what? EC is equal to what? And then after that, find the size of angle X, angle Y, and angle Z. Let's do this A and B in 5 minutes. Welcome back, Cretans. Let's mark our work. Right, AD is equal to what? AD is equal to PT. We can see from these symbols, isn't it? So we're given that AD is equal to PT. Okay, and then what about EC? EC is equal to AE. Okay, right. It does not mean that AD is equal to AE. No. AE is equal to EC, and then AD is equal to PT. Meaning what? Meaning that D is the midpoint of AB and E is the midpoint of AC. Okay, we haven't started the midpoint thing, we're just doing our baseline activity. Right, and then we need to find the value of X. Let's look at our big triangle, ABC. What can you say? We have two angles, 40 and 82. So we can easily find X. Okay, because of the interior angles of a triangle, they add up to 180 degrees. So we can find X there, meaning that angle A plus angle B plus angle C must give us 180 degrees. Interior angles of a triangle, or you can just write angle sum in triangle. Right, and then if we add those and solve for C, we'll get that X is 58 degrees. That is 58 degrees. Okay, right, now after finding X, how can you find Y? How can you find Z? Okay, let's look at Z because it's here on the left hand side. So Z is equal to what? We're told that DE is parallel to BC from this. Then remember the geometry of parallel lines. Okay, corresponding angles, alternate angles, co-interior angles. Right now, Z is going to be 82 degrees. Z is equal to 82 degrees because these are what? Corresponding angles. These are corresponding angles. These two, they are corresponding angles. Okay, and then what about Y? Y again is corresponding to X, so it means these are corresponding angles. So Y is equal to 58 degrees. Okay, that's what you're supposed to do there in our baseline. We're done with our baseline. Right, let's look at our investigation now. Please follow these instructions. We are going to investigate what? The line joining midpoints of two sides of a triangle. That's what we're investigating. So consider triangle ABC. I want you to draw a triangle like this. Don't draw it using the measurements that I'm going to give you here. Okay, I am going to do the actual measurements. I'm going to do the actual measurement. You see the ruler. That's why I'm going to bring in the ruler and actually see the measurements. But on your side, there's no need to do that. You just write on your rough sketch, you write the measurements that I'm going to be giving you. Okay, make your diagram bigger, maybe a quarter to half of a page. Okay, let's draw the triangle. 1 minute. Right, welcome back, Cretans. Let's do our measurements. Right, I'll bring in the ruler. Do you see the ruler? What's the measurement or what's the length of this line? It's 14. Maybe it's not clear there, but that is 14 centimeters. 14 centimeters. Let's name this side BC. Please name it on a diagram. BC, like this. Name it BC. And then let's write the length of this line, which is 14 centimeters. Okay, let's do that. And then we're going to measure the other side. We're going to measure all the three sides, right? We measure this side. What is it? Oh, again, it is 14 centimeters. Do you see that? It's a coincidence that the sides are equal. 14. This type of triangle is what? A isosceles triangle. Right, 14 centimeters. Let's name that this vertex, let's name it A. Let's name it A. And then the length of AB or BA, 14 centimeters. Please write it on your diagram. Remember, I said your diagram must be a rough sketch. Does not need to, you do not need to use these measurements, just rough sketch. And then you write what I give you. This is 14 centimeters. Okay, let's measure the other side, the third side. AC. What is AC? Let's hope it's not 14. Yes, it's not 14, it's 12. It's 12. This is 12. Right. Let's write 12 centimeters for AC. Right. We have all the measurements now. We have all the three sides of a triangle. Remember, grade 10 is what we're investigating. Investigation is very, very important. After this, you will never forget what midpoint theorem is. I promise you. After this, you will never forget what a midpoint theorem is. Because you have seen it, you have investigated, and you found it, you have seen it. Right. Now, we need to investigate what? Let's go back. Line joining midpoints of two sides of a triangle. So we pick any two sides of a triangle, and then we mark their midpoints. And then we join those midpoints. And then we're going to have that line segment, which is joining the two midpoints. And then after that, we check the properties of those of that line. Okay, now the next step is to mark our midpoints. Again, we need our ruler for that. Let's go back and get our ruler. Let's mark half of 14. What is half of 14? 7, isn't it? So it means the midpoint is going to be at 7. Let's name this midpoint, let's say D. Let's name it D. Okay, let's name it D. Right, please mark your midpoint roughly. Estimate there. You don't need to use a ruler, just estimate and mark it with the letter D. Right, let's measure the other side, AC. AC is 12. So half of 12 is 6. So it means the midpoint is going to be at 6 there. Let's name this point E. Let's name this point E. Right, okay, sorry for that. Now let's name this point E, and then we have our midpoint. Do you see that? Remember what we're investigating. We're investigating a line segment joining the midpoints of the two sides of a triangle. Okay, right. Let's just join the midpoint. The midpoints. Yes, we have our line segment DE, which is joining the midpoints of the two sides of a triangle. Midpoint of AB, midpoint of EC. This investigation, remember, it can be done with side AB and BC, can be done with side AC and BC. Okay, so I'll just use side AB and AC for our investigation, but it can be any of the two sides. It can be any of the two sides. Right. I want us to measure DE and see what will be the length of DE, this line segment which is joining the midpoints. Let's measure it. Interesting. 7 centimeters. Now, what do you think? Look at DE and BC. What can you say? What's the relationship between these two? DE and BC. Do you see that DE is half of BC? Very good. That is the one point that I want you to take note of. DE is half of BC. A line segment joining the midpoints of two sides of a triangle is half the length of the other side, the third side. In this case, our third side is BC. Is half the length of the third side, in this case, which is BC. So BC is 2 times DE. Or you can say DE is half of BC. Okay? Right. That's the first component for the midpoint theorem. There's one more thing that we need to check. I want us to do this. Let's measure the perpendicular distance between DE and BC. The perpendicular distance between these two lines. Okay, I'll draw a line. Dotted lines can do that also. Just dotted lines go down. Must be perpendicular. Right? Can even indicate that with a right angle. Right? Let's measure 5,5. Let's write that. Even if yours is not 5,5, it's fine. Okay, 5,5, write that. We come this side. We also measure. We measure from here. Where is it? We measure this one. Again, 5,5. So what does this give us? Or what do we observe from this? DE and BC are equidistant from each other. So what type of lines are those which are equidistant from each other? Remember Euclidean geometry, geometry of straight lines. They are called what? They are parallel lines, right? They are parallel lines. So it means DE is parallel to BC. Now, there are two things we have investigated and managed to find out. A line segment joining 2 points, joining the midpoints of 2 sides of a triangle, joining the midpoints of the 2 sides of a triangle. 1 is half the size of the third side. 2 is parallel to the third side. That's the midpoint theorem. Done. Okay? Right. Let's write it down now. Let's write it down. Where is it? Okay. The midpoint theorem states that. The midpoint theorem states that. Okay? The line segment joining the midpoints of 2 sides of a triangle. We're going to take our time on this because this lesson is basically for this. Okay? I want you to understand this part. Then application is easy. The line segment joining the midpoints of the 2 sides of a triangle, what does it do? If you think of theorems, what are you talking about here? What is this thing that you're talking about? What is it doing, or what are its properties? Now we're talking about the line segment joining the midpoints of the 2 sides of a triangle. Then what about this line segment? Okay, right. So this line segment is what? It is parallel to the third side. We found that in our investigation, and equal to half the length of the third side. That's the midpoint theorem. And then you can write your reasons. Remember, in Euclidean geometry, we have acceptable reasons. You don't need to write the whole sentence. Okay? How do we write it? We can say midpoint theorem like this. Write your notes. I'm going to give you 2 minutes to write your notes. Right, welcome back, Cretans. I really hope you managed to write your notes. Let's continue. Right, before we go to the application of this theorem, we're going to do application, like questions where we use this theorem, and then after that, we're going to do the proof. Right, I want us to look at the converse theorem. Remember, every theorem will go with its converse, which is like the theorem put the other way around. Right, now look at this triangle, ABC. Right? What can you say about AD and BD? They are equal, isn't it? They are equal, meaning that D is the midpoint of AB. I want you to understand this so you can differentiate between the theorem and the midpoint theorem and its converse. Right. The theorem, remember, it was two midpoints. And then we said if those are the two midpoints, then the lines are parallel. The line segment is parallel to the third side and equal to half the size of the third side. But now, we are only given one midpoint, which is D. What other thing are you given there? Look at the diagram. What else are you given? We are also given that DE is parallel to BC. So a line drawn from the midpoint of one side of a triangle parallel to the other side. You see that? DE is drawn from the midpoint and is parallel to BC. Then what does that line do? Okay, that's the converse of the midpoint theorem. So we're saying that a line drawn from the midpoint of one side of a triangle parallel to another side, that's the line DE. And then what does this line DE do? It bisects the third side. Bisecting means what? Dividing into two equal parts. Meaning that this line DE will cut or divide AC into two equal parts. Meaning that AE is equal to EC. Okay? The line drawn from the midpoint of one side of the triangle parallel to another side bisects the third side. That's the converse of the midpoint theorem. Please write it down. Let me give you 2 minutes to write your notes. Don't forget to write your acceptable reason. 2 minutes. Right, welcome back, Cretans. Let's continue with our lesson. Right. Example. Consider triangle KLM. Do you see triangle KLM? And that P and Q are midpoints of KL and LM respectively. So what can you say? PQ is parallel to what? PQ is parallel to KM. And then there is the midpoint theorem, because we're told that P and Q are what? Midpoints. Don't forget the reason. Okay? And then PQ is equal to what? PQ is half of KM. PQ is half of KM. Because of what? Midpoint theorem. I didn't write the reasons here, but make sure you write the reasons every time. And then KM is equal to 2 times PQ. I think we are just repeating this, okay? All right. So we're done the investigation. Now we're just what? Applying what we've learned. Right, this is an activity I want you to try. Consider triangle KLM, and then that PQ are midpoints of KL and LM respectively. PQ is 7 centimeters. Angle L is 62 degrees. Angle M is 45 degrees. Determine with reasons the length of KM, and then the magnitude of angle K, and then the magnitude of angle Q2. Let's do this in 5 minutes. Right, welcome back, Cretans. Let's mark our work. What is the length of km? Remember, we're told that P and Q are midpoints. P and Q are midpoints, meaning that PQ is parallel to km. PQ is parallel to km, okay? So it means km is going to be 2 times PQ, 2 times 7. And then what is 2 times 7 is 14, okay? 14 centimeters. The reason, midpoint theorem, right? And then since PQ, P and Q are midpoints, it means PQ is parallel. PQ is parallel to KM. Am I going to use that now? No, we're finding what here? We're finding K. Okay, for K, we don't need the parallel lines. You can use the interior angles of a triangle there. K plus M plus L will give us 180 degrees interior angles of a triangle. Okay, and then we can find our angle K, which is 73 degrees. Okay, this angle is 73 degrees. Right, and then this part now where we're finding Q2, that's when we have to remember that these two are parallel because P and Q are midpoints, right? So it means P and Q are, PQ and KM are parallel. Now, what will be the size of Q2 now? What will be the size of Q2? We have this angle and this angle. What can you say about these two angles that I've highlighted? They are co-interior angles. They are co-interior angles, meaning that Q2 and the 45 degrees must add up to 180 degrees. Co-interior angles, that's the reason there. And then we solve for Q2. Q2 will be 180 minus 45, which is 135 degrees. So Q2 is 135 degrees. Okay. All right. So that's what I wanted you to do then. Do you have another question? Oh, now I've written a lot of things there. You can see what is happening. Right. Now, this is another question. Activity 2. AC is equal to 30 units. AC is equal to 30 units. And then D and E are midpoints. D and E are midpoints of AB and BC respectively. Prove that BDE is similar to triangle. Triangle BDE is similar to triangle BAC. Prove that triangle BDE is similar to triangle BAC. I want you to try this in 5 minutes. Right, welcome back, great tense. Let's do the similarity. Do you remember similarity? Right. How do we prove that the two triangles are similar? If they are equiangular, like angle, angle, angle. If the corresponding angles are equal. Okay, let's do that. So this is actually giving you a clue. Before we do the proof, remember, DE is parallel to AC because of the midpoint theorem. We're told that D and E are midpoints. So meaning that DE is parallel to AC, right? And then now we need to prove what? Similarity. It's very easy when you're given this statement here. It's very easy. We have triangle BDE, we have triangle BAC. We just have to check, right? Angle B in triangle BDE goes with angle B in triangle BAC. Just check now, why are these two angles equal? They are equal because B is a common angle. It is found in triangle BDE and also BAC. So it's a common angle, right? And then you check, in triangle BDE, we have angle D, and then we have angle A in triangle BAC. So why is this angle? It's going to be D1. And these two, why are these two angles equal? Angle A and angle D1. Why are they equal? You see that? It becomes very easy. Now just looking for the reason, right? They are equal because they are corresponding angles. Because DE is parallel to AC. These are corresponding angles. And then you come to E and C. E goes with C. So it means it should be E1 here and angle C there. Why are they equal? So once you're given this statement, it becomes very easy to prove similarity. And then we can say also they are corresponding angles. Okay. Now we've proved that the corresponding angles, just don't confuse the corresponding angles there. When I'm saying corresponding angles, like E1 going with EC, D1 going with AC, with angle A. Okay, so now the corresponding angles are equal, meaning that with their, these two triangles are equiangular. Therefore, triangle BDE is similar to triangle BAC. Okay, we've managed to prove that. And then question B is very easy. So I'm going to give you 1 minute for question B. Let's do question B. 1 minute. Right, welcome back, great. So DE is going to be what? DE is half of AC because of the midpoint theorem. So meaning that DE is 15 units. Okay, right, becomes very easy for you to do corrections as I explain. Once you have done something, if you have done something. So make sure if I give you an activity to do, try to do that activity. Then as I explain, you can easily correct your work, maybe using pencil, and then we move together, okay? Right. Now let's go to C. I'm going to give you enough time to do C. Right. If BD, check, BD is 20 units and BC is 50 units, prove that angle BAC is 90 degrees. How can we prove that an angle is 90 degrees? An angle of a triangle is 90 degrees. Okay, let me give you a clue. Remember the converse of what? The Pythagoras theorem. Converse of Pythagoras theorem. Right, what does the Pythagoras theorem say? Hypotenuse squared is equal to the sum of the squares of the other two sides. If a triangle is right angled, then hypotenuse squared is equal to the sum of the squares of the other two. Then the converse will say, if the square of the hypotenuse, or if hypotenuse squared is equal to the sum of the other, is equal to the sum of the squares of the other two sides, then the triangle is right angled. Let me repeat it smoothly now. If hypotenuse squared is equal to the squares of the other two sides, or is equal to the squares, what am I saying? Is equal to the sum of the squares of the other two sides. It's a bit difficult. If hypotenuse squared is equal to the sum of the squares of the other two sides, then the triangle is right angled. I want you to try and use that to prove that triangle or angle A is a right angle. Let's try to do that in 5 minutes. Right, welcome back, Cretans. Let's mark our work. So now, we're told that BT is 20 units, and BT is equal to DA. Do you see that? BT is equal to DA. We're given that because of these symbols there, or D is the midpoint anyway. Right, so it means AB, the whole AB, is 40 units. Right? So AB is 40 units and AC is 30 units. The angle we want to prove if it's 90 degrees or not is A. Let's look at the side opposite that angle A. That is BC. So it means BC should be our hypotenuse if ABC is a right angle triangle. BC should be the hypotenuse. So what we can do, let's find the square of this hypotenuse. Let's square this hypotenuse, 50 squared, okay? And then we find the sum of the squares of these sides, 40 squared plus 30 squared, and see if they're giving us the same answer. If they're giving us the same answer, then it means that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Meaning that our triangle ABC will be a right angle triangle and angle A is a right angle. Does it make sense? Okay, so now let's find 50 squared. What is it? What is 50 squared? 50 squared is equal to 2,500. I've said left hand side, like the hypotenuse squared. And then right hand side of the equation, we have 40 squared plus 30 squared. What is it? 2,500. So the square of the hypotenuse is equal to the sum of the squares of the other two sides. Therefore, triangle ABC is a right angle triangle. And this angle A is going to be 90 degrees. That's our right angle. So A is a right angle. Therefore, triangle ABC is a right angle triangle. And then there is in converse of the Pythagoras theorem. Okay, right, that's what you're supposed to do there. Right, and then I'm going to give you this as homework. I'm going to give you this as homework. I want you to write this. I'm going to give you 2 minutes. Write this, and then draw the diagram, rough sketch, but should be a neat one. And then after that, we'll just discuss on how to do this. And then you'll do it as your homework. Just 2 minutes. Let's try this. Welcome back, cretins. Let's just discuss. And then you will try this during your own time, okay? Right, proofs. When it comes to Euclidean geometry, I want you to remember this. One, remember the construction that you have to make. Remember the construction that you have to make. All the proofs that you're going to do, even the grade 11 ones, grade 12 ones, you have to construct, create lines, okay? Two, remember theorems that you're going to use, or any other concept that you're going to use. If you can write this one down, it's fine. So construction, I'm going to show you the construction. Right, remember, when you're doing the proof for the midpoint theorem, you're going to use congruency. Write it down, congruency. And then after congruency, you're going to use the properties of a parallelogram. Properties of a parallelogram. Right? Properties of parallelogram will be the same as the properties of what? Of parallel lines, because parallelograms are composed of parallel lines. Okay? Right. Remember that. Construction. Let me show you the construction. You extend your line that is joining the midpoint. So in this case, you extend your DE. Construct a line segment that is equal to DE, like this. And then you can name it, like we name it F. So DE and EF must be equal due to construction. Okay? You construct equal. EF must be equal to DE. And then you join like this. I've done here. And then you've created a quadrilateral. I don't want to say a parallelogram now because we haven't proved that. And then you create a quadrilateral. That's the first thing you do. That's the construction. And then prove the congruency for these two triangles. These, the ones that I've shaded. If you can check them. This angle is equal to this angle, vertically opposite angles. Just listen for now. And then you can use this later. And then this side is equal to this side, you are given. And then this side is equal to this side by construction. We constructed. So now we have side, angle, side. We have proved that the two triangles are congruent. Remember, I said you are going to use congruency. And then from congruency, you will see that AD is equal to CF. AD is equal to CF. And then AD is equal to BD, you can see that. And then AD is equal to CF, you can see that. Therefore, BD is equal to CF. So we have proved that the opposite sides of this quadrilateral are equal. And then we just need one more condition to prove that they are parallel. Once you prove that the opposite sides of a quadrilateral are equal and parallel, then your quadrilateral is what? Is a parallelogram. Right now, from congruence again, you will see that this angle is equal to this angle from congruency, from a statement for congruency. If the alternate angles are equal, then the two lines are parallel, meaning that this line and this line are parallel, meaning that BD, we can say BA, but we're interested in BD here. BD is parallel to CF. Therefore, we prove that BD is parallel and equal to CF. Therefore, BCFD is a parallelogram. And then you can use the properties of parallelogram now to prove that DE is parallel to BC because these are opposite sides of parallelogram. And then DE is half of BC. Why half of BC? Because DE is half of DF. DE is half of DF and DF is equal to BC. Therefore, DE is half of BC. Okay? It's a lot, but I really hope that this will assist you to try and prove the midpoint theorem. Try. Keep on trying. Do it again. Do it if it means doing 5 times, 10 times. It's okay. Till you master it. Okay? Thank you very much, great turns. Let's take a short break, and then after break, we just summarize our lesson.
Dreams. What is your dream? Yini phupho lakho? Not your parents' dreams, not your mom's dream for your life. What is your dream? Is it to get a bursary? Is it to study science? Is it to become a DJ? Is it to become a singer? What is your dream? Iphupho lakho. Once you have that dream, what I need you to do, I need you to write it down. Ingole mofati. Write it down, ibhale phansi, and read it each and every single day when you wake up. Read it each and every single day before you go to bed, and remind yourself of where you want to see yourself. What is your dream? Write it down, meditate on it, and go after it with everything that you have.
Welcome back, greetings. We have said the midpoint theorem states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and equal to half the length of the third side. The line drawn from the midpoint of one side of a triangle parallel to another side bisects the third side, that's the converse of it. Right. Oh, thank you very much, greetings. We are going to meet the other year. I wish you all the best as you go to your grade 11. Enjoy the rest of the year. Thank you very much.